Craig? Craig Labowitz is up next if he's around. I haven't seen him. Oh, there he is. Okay, great. Craig was, if I remember correctly, Craig was NANOG program chair back in the day. One of a long line of distinguished program chairs from Merit, or wherever in those days. And I'm pleased to introduce Craig as sort of our first speaker this morning.
Okay, sounds good. You guys left me some extra time?
Yeah.
Can I use the wireless as well?
I think so. She's telling me.
What's that?
She's telling me how to operate Windows. I don't know how. What kind of Unix is this? Control L. Thank you. Thank you very much. That's helpful.
Okay, great. Is the mic working? Okay. Well, thank you. My name is Craig Labowitz. I also work with Farnham, and it turns out I've worked with most of the folks on the podium here at one point or another. Today I'll be speaking about really what was a 2-year effort, a very large effort, and a very large collaborative effort between the University of Michigan, Merit Network, and Arbor Networks. And I initially was going to say that I didn't quite have enough time to make it through the entire deck, so I was going to aim for a sort of a speed in between a Kim Claffey and a Paul Vixie, but I think Farnham very politely left me enough time to perhaps make it through the deck. So I'll begin talking about the Atlas Internet Observatory, the 2-year effort. Really over the last 2 years, we've managed to work with a commercial vendor who has now equipment deployed in maybe 70, 80% of large Tier 1, Tier 2, regional, and many of the content providers around the world. We've been able to leverage this infrastructure and do something that I think is quite extraordinary. We've been able to somehow convince 110 of these large content ISPs literally around the world to do something that I previously wouldn't have thought they'd be willing to do, which is share data, particularly some security data, and at least coarse-grained traffic engineering data. So today, Atlas represents what I will unabashedly claim is perhaps the largest internet traffic monitoring infrastructure in the world. We're monitoring about a peak of, give or take, 14 terabits per second. I think in an upcoming tech report, we make the claim it's approaching 300 exabytes of data offered load through the last 2 years. And again, it's real-time traffic engineering and security information. And I'll stress on this slide, and I'll stress through many of the slides, that all the data is anonymous and the participation is voluntary. So it's a subset of the commercial deployments that indeed have agreed to read the legal language and enable the anonymous stats on the checkbox. Also, just before I get into the meat of the report, I should just be I think, frank, that I think most of the results we have are not things that haven't appeared in the press before, or haven't appeared at NANOG or in other research papers. There's been lots of discussion in the past about how big is Google, was YouTube a good acquisition, a bad acquisition, is Google making money, losing money? There's really no shortage of articles, folks estimating the size of the internet. I just read recently about the great exaflight, that since it didn't come last year, it's going to come any year now, much like the biblical end of the world approaching. But there's been a lot of, I think, press written about aspects of this, and some of it quite good. I think one of the key challenges, though, is it's quite hard getting quantitative data about these trends, whereas most of the previous analysis is based on secondary indicators like routing table growth, BGP, market filing data, and so forth. So I think that this really represents one of the first large-scale quantitative studies of internet evolution over the last 2 years, using quite a bit of data. I'm sorry? Something's turned on. Okay. Is this better? Yeah. Should I repeat everything I said? Okay. Actually, now I'm getting feedback, so perhaps I'll just give up on this and stand next to the mic. So as I mentioned, that there's been quite a bit of related work. Certainly Bill Norton's written about the evolution of video. We have Akamai doing regular reports now. Andrew at Mintz has written quite a bit about doing size estimates of the internet based on exchange point data. So this list by no means is exhaustive, but certainly there's quite a bit of effort out there. Again, some of it quite good. With that, I'll segue into a brief discussion about methodology. So as I mentioned, we're leveraging commercial infrastructure deployed around the internet, around the globe. Have to pose for Roland over here. Commercial infrastructure that's fairly widespread. Typically, the infrastructure, about 90% to 95%, is getting data from routers, sample data, based on flow, S-flow, J-flow, whatever the name du jour is. About 5% or less probably is port span or inline deployments, getting data. Typically, these deployments are around the peering or transit edge of the network, and for these 110 providers really monitoring most of the peering or transit bandwidth. Other deployments are customer edge, other aggregation edge, but by and large, really the transit edge of the networks. Every hour or half an hour, depending on the deployment, these deployments will send up an anonymized XML file up to a central server. We don't track from where the files came from, and there is no customer or otherwise ISP identifying information in the XML. And as I said, the Wired likes to compare this to the NSA, and I really wish they'd stop doing that. This really is nothing of the sort. This is just AS level, very coarse-grained data. There's really not any fine-grained visibility. There is no fine-grained visibility at all in the data. So that's a high level of the observatory. And just, again, before I get into the meat of the report, just want to spend a minute about what we're measuring and perhaps more importantly, what we're not measuring. So the observatory data really, I believe, provides fairly good insight into the relative traffic between ISPs, interdomain data. We are monitoring 110 ASs, give or take, out of whatever the number is today, 35,000, 37,000. With that said, the 110 we're monitoring, we believe, represent, as perhaps Randy Bush would call it, the clue core, which is the larger tier 1s, tier 2s, the larger content providers. And again, the distribution of ASN tends to be really heavy-tailed in terms of traffic distribution, where it really is the first 300 or 400 by far dominate the traffic. And then you've got a trailing, very long trailing edge of thousands and thousands of multi-homed enterprises. Based on telegeography and Forrester data, we believe our distribution roughly approximates what we'd expect from the commercial data or analyst data. And our focus throughout the report really isn't on absolute traffic volumes, but for the most part through all the slides, we're really looking at percentage, our estimated percentage of all internet traffic. And that's really for a number of reasons, including the fact that the data is a little bit noisy as people add routers, lose routers, join the anonymous deployments, leave, and do all sorts of things that I don't think I could ever explain. So it is a very noisy data set. With that said, interdomain traffic, I think volume and ratios, do provide a very important perspective on one of the key metrics of internet engineering. Again, peering ratio, estimates of traffic are really how we design the network. In fact, are behind many of the commercial and negotiation strategies. With that said, I will stress what we are not measuring. The system is not measuring web hits, tweets, commercial transactions, customers, or anything of that fine-grained detail. It, by definition, is monitoring interdomain traffic, so it does not have visibility into VPNs, VoIP services, video services, and so on. And perhaps most critically of all, traffic is an important metric, and percentage of all internet traffic is an important metric, but it is only indirectly or vaguely related to anything like ISP success or profitability. So please keep that in mind as we go through the deck. So I'll jump into the major findings. As I said, I think that there's been a lot of text written by analysts and even other academics about these changes. I think I was struck by really how quickly these changes are occurring and really how dramatic some of the shifts have been even over the last 2 years. It used to be the case, I think, at least in the popular imagination, or at least I use my mother as an estimate of the popular imagination, that the internet was this very democratic, nebulous cloud, and she believes that when she's connecting to, since we're in Detroit, a car company website, that she's really going to a server in the Ford building across the street. that the internet really is distributed, and content is really distributed across hundreds of thousands of data centers and websites. Of course, what my mother doesn't realize is that likely she's going, and this is for you, Patrick, she's likely going to Akamai, or she's going to Limelight, or she's really going to Rackspace Data Center, and so forth. But we'll show coming up in a few slides a really dramatic change in the distribution of traffic across origin ASNs over the last 2 years. Really the traffic migrating out of the edge, out of the enterprises, into large carriers, as well as consolidation amongst the Googles and Microsofts of the world. Perhaps the most compelling result in the slide deck I'll come to in I think 3 or 4 slides is that in 2007, it really was the case that thousands of ASNs contributed, really you had to get to basically several thousand ASNs to reach 50% on average of internet traffic. As of July 2009, you only need 150 origin ASNs to generate 50% on average of all internet traffic. So a very dramatic shift. Not only has where the traffic been coming from shifting and consolidating, but also the applications have been changing as well. Basically, over time, more and more traffic is migrating to the web, and we're seeing declines basically in all other well-known ports and application groups. The one way I think of this is that the great vision, the great battle for the end-to-end network has been fought, and it's been lost. As IPSs, IDSs, firewalls, even Microsoft recently converted Xbox, which used to use all of its own protocols and ports, just to port 80, presumably to simplify some of the headaches of customer management and configuration. So increasingly we're seeing a shift to port 80, and increasingly I think the data belies the shift others have written about the web increasingly being the front end for mail and all other applications. Finally, I think the most interesting point, at least from my perspective, is that what really is fascinating about the changes is the degree of economic change and logical topology change. That we're seeing for the first time, I think we've crossed the threshold where the majority of traffic now flows directly between consumer and content networks. Over time, the average BGP path has been dropping from 4 hops, maybe 7 years ago, to 3.5 hops, to 3 hops. And we're seeing even more dramatic shift when you look at traffic as opposed to AS path distance. Along with the shift, we're seeing most ISPs shift from focus on connectivity to focus on content and higher value services. I should mention, too, as we did this report, we spent a lot of time talking with maybe 30, 40 different providers, walking through the data, trying to gain insight into the trends. And although most of this was under NDA, most of them did describe very significant economic innovation, particularly experimentation with things like paid transit, new models of hybrid with paid transit settlement free, and things like paid content, which I'll talk about shortly. So I'll segue into a discussion of the Internet core. So I used to teach classes about Internet and Internet routing, and this comes from a textbook. And for the most part, the nice hierarchical model that we got out of the end of the NSFNet and the large tier 1s at the core with all traffic and generally most monies flowing up from the consumer networks, enterprise networks to regional, then to from local, then to regional, and into a core. For the most part, I think that this rough logical model held true, modulo the name changes. I think perhaps only Sprint is still has kept the name, though I do still have an Aegis coffee mug on my desk at work. And when we actually look at the data, again looking at all ASN traffic, from the perspective of the 110 ISPs giving us anonymous traffic data, I'll stress again in the gray box that the data here we have has no relationship to observatory participants. The analysis here is based on the view of these ISPs from all of the other ISPs around the world. But roughly in 2007, July, the top 10 ISPs in the world roughly correspond to what you'd expect from tier 1s. And by the way, rather than get into a long discussion about what is a tier 1, what is not a tier 1, I'll say whatever Wikipedia says is truth. So this does correspond to, I think, the page Patrick helped edit on the list of tier 1s. And again, this is a weighted average percent of all traffic, with level 3 global crossing at the top and the other tier 1s. But then, what was true for maybe 10, 12 years of the internet, the world has been changing. It's been changing for a long time, but the changes have really accelerated over the last 2, 3 years. Certainly everyone in the room has been familiar with many of these bullet points. The price of IP wholesale transit has been dropping and dropping quickly over time, while at the same time advertisement-supported content and revenue has been climbing dramatically. More recently, we've seen the entrants like Panther and others really depress the price of CDNs, where the price or the cost for an enterprise to host their content in a CDN has dropped dramatically over the last 2, 3 years. And we continue to see a real scarcity, I believe, in some of the more modern data centers, particularly as cooling, not heating is the opposite problem, as cooling and power virtualization have changed the footprints and really made older data centers much more difficult to operate efficiently, as well as raising the bar in the market entry to build new internet scale IDCs. So these two slides actually aren't my data. One of them is actually from Bill Norton and Dr. Peering. I can't really read even I can't read what the graph is showing in the top, but suffice it to say this is the price of IP wholesale transit and it's dropping. It's not at zero, but if you wait long enough, it'll get pretty close over time, is the general trend. The bottom graph is showing the price, again, I should mention both of these data sets you can find in telegeography and Analysts. Wall Street Journal has had similar graphs. I think this is interesting data, but I think it's fairly well documented as well. The bottom graph is showing really the inverse, that as IP wholesale transit has dropped, you've seen a very dramatic growth in the amount of money being spent on advertisement-supported content. And these really are two of the really key macro-level economic trends that really have been reshaping the way ISPs think about the internet, the way they negotiate, and really the underlying topology in the economic system. So very large forces at work, which quite literally are reshaping the internet over time. And I'll explain what I mean by that. So those forces all bring us to the Atlas 10 today in July of 2009. The left-hand chart is the data I showed previously, and on the right-hand side is the data from July of 2009. I should mention that I think in the tech report we'll have the full list of the top 10 or 20. I think we still want to focus on, the results, and we want to be careful with, just some of the commercial sensitivity of the data and showing, declines or other changes in ISP traffic. But on the right-hand side, you'll notice that level 3 and global crossing, particularly given some of the very large content that they're hosting and some of the sites behind them, have grown in the percentage of internet traffic. And what I find really the most interesting is here you have two companies that really weren't anywhere close to the top 10 in 2007. I mean, weren't even the top 20 in 2007, are now in the top 10. And these are companies that aren't typically, are in fact not on the Wikipedia page for Tier 1, at least they're not there today. And they're companies that typically are not in the business of providing, at least weren't in the business of providing transit. So you now have Google at roughly 5% and climbing, perhaps one of the fastest growing origin AS groups or AS groups on the internet, and Comcast making the top 10 as well. I should mention again that this is based on weighted average percentage of all internet traffic, of all the 110 ISPs exchanging traffic with Google and Comcast and Level 3 and so on. Has no direct relationship between observatory participation. And let me stress again that I think we've been often misquoted or misperceived that Tier 1s are still very, very large. Tier 1s are still profitable, some of them, and Tier 1s are still carrying significant volumes of traffic. The point we're making is more about the change in trends and trajectory of the internet than saying that all Tier 1s have, all traffic has evaporated, because that's clearly not the case. In fact, some of the Tier 1s, or many of them, are in fact still growing their business. This, I think, is perhaps the most interesting slide in the deck. So if you've not been paying attention for the first, however long it's been, 10, 15 minutes, This is perhaps the one slide that is interesting. I should apologize, too, that this is a cumulative distribution graph. And even amongst academics, there's a running joke about cumulative distribution graphs, because most academics don't actually know how to interpret them. I mean, present company excluded.
Thank you, Craig.
You're welcome, Farnham. But I'll tell you what I think the graph is showing. We really have two lines plotting the distribution, the percentage of all traffic. The vertical axis is a cumulative percentage, and the x-axis is really the number of ASNs. So in 2007, or the red line, basically to get to the, I don't have a laser pointer, but to get to the 50% mark, it was really, really heavy-tailed. In fact, it was so heavy-tailed, we cut off the graph because it really goes off and off, way off into the distance. You really had to get into the thousands of ASNs to cross the 50% mark. The blue graph is showing July of 2009. In July of 2009, you don't have to get to thousands. You need to get to 150 to get to 50% or more of internet traffic. And this really is a very dramatic, very abrupt change in a 2-year period. I don't have time to get into it right now, but this more or less may be what you expect. It may not be what you expect. It may approximate a power law. I don't have the time or the inclination to get into a power law discussion, but it is very an exponential. It is a very abrupt power law distribution, and perhaps also was in 2007. But clearly, the knee of the curve has changed. So I'll pause on the slide and just let everyone get a look at it. Since this, again, I think is one of the most dramatic changes we've seen and really belies some of the economic and some of the logical changes that are occurring as well. One of the key components that's really driving the change, we call them hypergiants in the tech report coming out soon, really because black hole had a negative connotation, so the next biggest was hypergiants. But hypergiants are really the 150, the couple hundred large ASNs at the far left hand of the curve. One of the key components of the hypergiants really are the CDNs. And there's been very significant growth in both the number of CDNs as well as the traffic volume of the CDNs. In this graph, we're graphing over time the top 5 pure play CDNs by grouped origin ASN. And again, this is weighted average percentage. I should mention that saying pure play CDN is perhaps increasingly a misnomer, as all CDNs basically now offer transit and other typical carrier services. And then you've got most tier 1 ISPs and even many tier 2 are offering CDN. So the distinction between all of this is increasingly blurred, and I'll leave it to far more educated analysts to draw these market segment boxes than I'll ever attempt. But I should mention, too, just so Patrick doesn't send me more email, that we're only really graphing the interdomain traffic due to Akamai here. That Akamai, as many of you know, of course, typically has boxes deployed within the provider IP space, but we're really just seeing the data that's going to update the caches and not all of Akamai traffic. In fact, we would guess that Akamai traffic overall is probably a third or quarter. We're only seeing a third or quarter of the Akamai traffic. But over time, CDNs as a group, we'd estimate, are approaching about 10% or thereabouts of all internet traffic is coming from a CDN. And again, when my mother thinks she's going to the Ford web page, she's most likely not, and it's most likely, again, coming from one or more of the CDNs. So fairly significant changes in the distribution of traffic across origin ASNs, fairly large growth overall in CDNs. And I don't have the slides in this deck, but there's been fairly significant changes in the sort of AS level distance, or the distance traffic is going as it goes from content and consumer, where of course it's getting pretty close to zero through direct peering. I think the question is what's happening and what's really driving all of these changes. So clearly commoditization has been occurring and accelerating for quite some time, much like other industries at the turn of the century in oil or other commodities. The price of IP wholesale has been dropping. Price of CDN and video delivery in particular has been dropping. And we're seeing a lot of enterprises just it no longer makes economic sense for enterprises to host their own content. So we're seeing all that content migrate very quickly into the cloud. We're also, of course, seeing consolidation. It used to be that YouTube, PhotoBucket, I could probably go on for tens of minutes. All of these smaller companies were once smaller companies. Many of them had their own ASNs and their own traffic and their own infrastructure. Today, they do not. The big get bigger as Microsoft and Yahoo and Google vie for market share and dominance of really the portal and the interface to the new internet. We've also seen, I think, real success both from the tier ones, folks offering business enterprise services in bundling services and delivering things that may have been purchased from other carriers or other suppliers in the past. These are MSSP and video and backup and other delivery services. And we're seeing folks like Comcast and others see great success with the triple play, now the quad play, and I'm even told there's a quintuple play coming. But also belying all these changes are also new economic models. And this perhaps is the hardest to quantify since a lot of this takes place under NDA. But there's a lot of experimentation with paid content, such as ESPN 360 or the Sky in the UK. We're seeing a lot of folks experiment with paid transit. And more, I think most broadly, what we really are seeing is, in economic terms, disintermediation. Where in the economic sense of the word, this really means removal of intermediaries from the supply chain. As both folks like Google and Akamai and others are looking both at cost, but increasingly it's not about cost, it's actually about performance. As the CDNs and the hosters and others have SLA-based metrics and very interested on getting the best performance from the content to the consumer. So this brings us at least to my diagram of what if I to show what the new internet looks like. Increasingly, the data shows the new internet really looks like a much more densely interconnected cloud of large consumer and content, all direct peering, whether it be settlement-free or paid transit or other things under NDA. The tier ones are still large. They still are a critical piece of the infrastructure. They're not going away. They're very large amounts of traffic. But there is now a very new significant component of directly connected content and consumer. And I think that, there really is no local provider anymore. The locals have all been absorbed in the regional, so we have a much flatter internet as well. Just a quick case study. I have a case study on Google and a case study on Comcast. This is looking at Google's weighted percentage of internet traffic, again, from the perspective of 110 ISPs who exchange traffic with Google. We also plotted YouTube's ASNs in the red, mainly to give a sense of how much of Google's growth may be due to the YouTube and folding YouTube traffic into the Google ASN and Google infrastructure. So you can see Google has absorbed YouTube over time, and Google represents really one of the fastest growing collection of ASN in the internet today. I think when I recently looked at it, it topped 6% and was still climbing. Again, you can say what you want about was YouTube a good idea or a bad idea, but this is, I think, a fairly dramatic change to make an acquisition, albeit for several billion, but to gain 6 or 7% of internet market share, at least by traffic volume, is a pretty dramatic shift from less than 1% 2 years earlier. Next, since we talked about Google earlier, Google made I think it was number 6 on the slide before. And Google, I think, caught our interest as trying to understand how did Google go from 30th, 40th, it wasn't anywhere near the top 10 earlier. Well, in 2007, Google looked like a typical MSO. It looked like a typical MSO from their peering ratios. It looked like a typical MSO in that they had more of a fragmented backbone than a single backbone. And they basically were dependent on a number of transit upstreams. They did very little external, or relatively, comparatively little external peering with other providers. By 2009, Comcast is different. Comcast, of course, enters the top 6 in terms of traffic volume of all ISPs on the planet. Their traffic ratio shifted from an eyeball network to a content, looking much more like a content or a transit network. And I'll show a slide of that coming up. And as we've talked to providers, around the net about what's happening, we've talked to analysts, it really seems to be the case that Comcast successfully executed on the triple play. They entered completely different business models like cellular backhaul, wholesale IP, voice transit, Metro Ethernet. So very different provider, and I think an interesting example of some of the transformations internet providers and even MSOs are undergoing as the internet evolves. And just quickly, this is a graph of the peering ratio of Comcast. Basically, the left-hand side, the vertical axis, is the peering ratio, how much is content versus how much is in versus how much is out. The x-axis is time. And you see that over time, Comcast shifted from basically a 65-70% eyeball network to whereas today they are most decidedly what I put in the content camp, due to, again, some of the changes in the business model. And as I mentioned, I find increasingly a bit of a misnomer to distinguish now between content networks, consumer networks, CDN, ISPs. We really are seeing consolidation, not just in the topology, but also in the business models, though, of course, it varies from provider to provider as well. So I'm going to shift gears with the last few minutes I have and now talk about some of the changing applications. So this is hard to read, or it might be hard to read, but hopefully you all have access to the PDFs. This is, as of July 2007 and July 2009, weighted average percent of traffic due to different broadly defined application groups or classes. I should mention that most of this data is based on well-known port analysis. We do have data from 5 or 6 payload-based deployments, which in the tech report we augment some of our analysis and discussion with. So, for example, peer-to-peer here is listed at, in July 2009, 0.85%. But based on payload analysis, we believe that most of peer-to-peer is obfuscated and or encrypted, and probably the numbers globally are much closer to 18 to 20%. Certainly very little peer-to-peer traffic actually is using the well-known ports. We have a similar issue with video, for example, and of course there's an awful lot of video within port 80, progressive HTTP download, namely YouTube and so forth. So I think broadly the conclusions we come from looking at both the well-known ports and the payload data is that web by far is the engine of growth in the internet, picking up 10%, and by the way this is change in overall internet traffic, not change in HTTP, followed by HTTP. So it really is web and video are the growth engines. Peer-to-peer is declining, and basically everything else is declining as more and more traffic migrates either to Flash or really to port 80. And I don't think I included the deck of port 80, but again, I think that's largely we're seeing just, again, the end of sort of the end-to-end argument as more and more application network designers migrate traffic to port 80 to evade firewall headaches and IPS and NAT and so on. I'll spend a moment talking about peer-to-peer. This is mainly because Wired and other people, as they describe it, peer-to-peer back in 2007 was the boogeyman of the internet. We had, for lack of a better word, alarmist articles in the popular press about the end of the internet was near, the traffic, the exaflood was coming, peer-to-peer growth was 60, 70%, all networks were bending down, FCC, there's net neutrality discussions, there's just an incredible amount of press all around peer-to-peer. So it's perhaps interesting that when you look at well-known ports as well as payload-based analysis of peer-to-peer, that by 2009, the great evil boogeyman of the internet is retreating, and retreating quickly. Again, this is market share. So absolute volumes of peer-to-peer may not have dropped as significantly, but as a percentage of internet traffic, peer-to-peer is not growing as quickly as other traffic forms, so it's losing market share. And in fact, we believe there's an absolute decline as well. So this is some of the most popular well-known ports, but the analysis is the same if you look at Korean ports, if you look at Chinese peer-to-peer, if you look at all other sorts of data sets. And I should mention that the trend varies by region. Asia actually has been much slower to decline in peer-to-peer than other parts of the world. So peer-to-peer, there are still significant volumes of peer-to-peer. Peer-to-peer is not gone away. It's still in some networks, it's still 30, 40% of all traffic. But broadly, we think it's closer to 18 to 20% globally on average today. And the growth has slowed, so that's declining in terms of internet market share from all other applications. I think when we look at the data, we talk to providers, we talk to analysts, we really come to 3 conclusions about why this shift is happening. Number one, there's clearly some evidence of provider traffic management. Again, providers in different parts of Europe and perhaps a few in North America actually doing different sorts of traffic engineering. But I don't think that's really the significant story, and neither is the next one, which is there have been significant improvements in peer-to-peer. It used to be the case when we look at peer-to-peer clients, again, it would as happily go to Asia to get a seed as it would to the other boxes on the cable head-in. So there's been very significant improvement, performance-based, topology-based peer-to-peer. But really, I think when we look at the data, it's just quite simply that peer-to-peer is a pain. To watch the latest movie, you have to wait 6-7 hours and you're not sure what you're going to get. Is it that shaky camera in the video theater with a guy standing up in front of you and coughing all throughout the movie? Or is it a true HD movie? You know, mainly peer-to-peer has been eclipsed by streaming, CDN, and direct download. And I should mention that by streaming and CDN, really it's the success of some of the commercial legitimate sources like iPlayer and iTunes and Hulu and so forth, as well as direct downloads, which have varying degrees of, I think, focus on intellectual property issues. This is just one example. And I like this graph because this very clearly allows us to distinguish the contribution of direct download. This graph is part of a quiz. Can anyone guess when Mega Video became a customer of Carpathia Hosting? I can't hum, so I'm running out of time, so I'll jump to the answer. It clearly was the dramatic spike, November of 2008, and you can see the very dramatic spike in the contribution. Really, overnight, Carpathia went from a very small, in terms of traffic volume, to now approaching 5.6% of all internet traffic. So I'll try to finish with just a few minutes left for questions. Again, there is a tech report coming out, which is 30, or by the time we're done, maybe even longer pages. Hopefully it will be out shortly, providing much more detail about all of this. But broadly, the Internet's at an inflection point. For the first 10, 12, 15 years of my career with the Internet, certainly the focus was all about connectivity, speeds and feeds. Today, we're really seeing the economic discussions, the academic discussions, the technical discussions really shift to content. And along with this, the old, for the last 15 years, we basically had only a handful of economic models of tariff meter-based Internet. We're seeing a lot of economic innovation as the business model, literally, of the Internet evolves. And we're seeing new entrants reshape what we mean by Internet and ISP and CDN. We're, of course, also seeing, I think, significant new technologies, which, like, whether it be netbooks or cloud, and I have no idea what cloud means anymore, by the way, but we're seeing, the cloud, the migration of applications to the web. And at least from, I think, an engineering community perspective, all of this is kind of cool. It means there's lots of work for us. It means there's lots of really interesting security challenges and engineering challenges. And finally, this is just the beginning. As we talk to some of the LTE folks, as we talk to other things in the mobile space and some of the cloud, we think the rate of change based on the data is accelerating and will be even more dramatic in the next few years. With that, I think of exactly 4 minutes for questions.
Hi, Craig. Thanks a lot for sharing this. One thing that jumps out at me is, of course, video is a much larger amount of traffic for any interaction one might have with an application, right? When you download a video, that's going to be lots and lots of megabytes versus downloading an email or Twitter or whatever. I'm wondering if that's kind of skewing things in the analysis. I mean, if the growth of video traffic goes pretty big, anyone who's carrying video traffic will show up very, very high in your analysis, right? So we're kind of discounting the importance of those who are not doing video. Would you agree with that?
Yes. I think in the tech report, it takes an awful lot of tweets to make up a single HD stream. Whereas, clearly as SMS has demonstrated, volume and difficulty of delivery don't always equate with pricing. Patrick, I did mention Akamai.
Yes, you did. Thank you.
Okay.
So in the report, you mentioned inter-AS traffic, and you mentioned that you try to group companies. So lots of companies, Telia, Tiscali, Telefonica, Comcast, et cetera, have a backbone, and then they have an AS with eyeballs in it. Are you measuring from their backbone, or are you grouping that together? Are you measuring the backbone to eyeball AS edge? or how does that work?
Yeah, it might be easier to take it offline because this gets a little bit complicated, but we did look at AS paths to avoid a number of issues, including double counting of ASN. So we tried to capture as close to the edge of the network as we could for the grouped ASN.
Okay. And just to add some data to the paper, Akamai's peering AS is less than 20% of our traffic.
Okay. Thank you, Patrick.
Since the gentleman from Carpathia has nothing to say, I'll ask a question. When you rank, so there are networks that are bigger on inbound, networks that are bigger on outbound, and you showed some of the ratio stuff. When you rank the networks by traffic, is that sort of ignoring the vector dimension of the traffic and just ranking total bytes seen in flows? So so if someone is number 5 or number 6, it could be all in, all out, or some mix?
Yeah, so in most of the ranking, it was in plus out, so it was the overall vector. Though we did do the analysis separately, which was, you saw, some vestiges of that in like the Comcast discussion, which is kind of an interesting metric in itself.
Is some of the data presented in the tech report broken out that way, or it's mostly just the in plus the out?
Maybe a little bit more. I think it's mostly in plus out. We ran out of room and time. And
Okay, thanks.
Yep. You already asked your question, Patrick.
No, I have another. Is this, what are the numbers, 95th percentile, peak, average, what?
The primarily average.
So bytes delivered total.
Yeah.
Okay, thank you.
Okay, I think I'm out of time. I should mention that my co-authors, Farnham and I think Scott and John are here. Danny's not here. I think he's hunting, trying to kill some wild animals, but thank you.